on geographic data and Python. So the purpose of this class is to give you just the basic outline, because there are whole degrees dedicated to just GIS data and just whole classes where people spend all their time learning about how to project, what to project, how to transform, and then some of the mathematical derivations for like flattening out a round shape to a flat shape. So then you won't be an expert after this presentation, but you certainly will know how to map a point or to map some of the data that you guys have. Okay, so let's see. Next. Okay, so again, objectives is basics of GIS. You'll know what's out there, at least what a few packages that I'm going to highlight. And then you'll be able to I'll have a couple suggestions for you if you want to map your information, and then walking through a couple of these visualizations and analysis. And unfortunately, or fortunately for me, it's only in Python 2.7. I think a lot of the packages, for instance, like Shapely says it's ready for 3.0, but I think some of its dependencies aren't yet. So I will walk through virtual environments in Anaconda, and then another virtual environment Python package that you can use for this information to create like your other 2.7 pocket where you like essentially create a visualization, output it, and then you can like throw it into a presentation. And so these are the sections I'm going to cover: definitions, coordinate systems, etc. So overall, what's GIS? So GIS is Geographical Information System, and I think one of the biggest misconceptions is that GIS is a whole collection of information. So then it's everywhere from the person to doing the GIS analysis to computer hardware, data, and then software. And then here are all the adjectives associated with working with map data or GIS data. So each one of these you can imagine is its own heavy lifting process, and we'll go over some of these pieces in a second. And then how you should think about building maps in Python. Essentially maps in Python that you'll be building are layers. So you're creating layers on top of each other, pulling from Geospatial Dataset, and then you're putting into a JSON object and using that JSON object to project onto your map. And then so we'll go over those details in a second. But essentially, being a non-geography GIS person, this is how I think about it, and then I get through a little bit of the mapping data. Friends. And so every data set has a coordinate system. Like Dan so always walks us through kind of like how to think about general coordinate systems are X and Y. And geographical data sets are a little bit more complicated than that. But essentially, the objective is, one of the hardest things to do in kind of like GIS, ETL, is taking whatever data set you have, figuring out what coordinate system they're using, and then projecting that coordinate system onto a common one so you can map the information together. But I'm guessing probably from any of your data sets, you won't necessarily be meeting that problem, because a lot of you will be looking at line data, so your polygons, but on like very common things like states, countries, right, cities, maps, maybe some ocean like polygons. You might do points, cluster of points, but you're not going to do like really crazy projections where you're trying to where you're trying to match up maybe maps done by one system to another. So I just have appreciation for GIS folks in this aspect. So the two major types of coordinate systems are geographical coordinate systems, and this is what you're probably most used to seeing is latitude and longitude, and this is primarily used for web maps. You're probably like, duh, which is good. And then so latitude and longitude is like the best type of data for measuring angular units, decimal degrees, so you can get area of a map, you can get area of your map, distance of your map. And then also, I guess, a geographic datum transformation is required, like that's what they call it, to project, to reconcile your projection as well as your degrees. So if you're on different coordinate systems and you have the same point, they'll be different. So then that's what actually a lot of we'll go over later. A lot of the mapping suites, they have these tools integrated into their suites pretty easily. So then you can go from one tool to the other. And then obviously the more open source you go, the more difficult that portion of that projection transfer is different. And then the second major type is PCS. So this is the projected coordinate system. And then I think this one's a little bit more complicated and to get your head around, and I'm saying for me, essentially you're taking a round object and you're smashing it. So like if you just think of when you it's okay. You actually you end up ripping that orange. So essentially all these projections are different ways of representing certain areas of the map with known distortions. So this map that I have here, it's it's trying to capture more of kind of where the center maps are, and then it's distorting as it comes out near the edges. So I'll show you a couple other different other projections, and then you can obviously see where the different distortions are. So the most common thing that you'd be asking for yourself if you're reusing maps that other people have is, what projection are they using, and can I integrate these two data sets together? So essentially the same thing when you look at two different data sets and you use pandas to merge them or to join them. This similar type of question, but different coordinate system. And then also within GIS, there's two major data types. One is vector and one is raster. So the vector one is what you're also most familiar with, is points, lines, and polygons. And so you can draw these very easily with a dictionary, a JSON file. You just have to have those points already mapped out. And for a lot of your major shapes that you're going to be using, which is states, counties, census tract, you can find those open sourced, like a GeoJSON shape file. And then we have raster files, which are raster file. I wanted to call it raster files, but that's not as fun. So raster files, which are cells, pixels, and elements. And then so what's more useful with rasters is for agricultural data, vegetation data, environmental data, where you can represent the information in the separate cells, and each cell has multitude of attributes. So you're oh, this cell on this let's say this aerial view of the Earth, this cell has vegetation, dirt, sand, or whatever in it. It has this whatever this particulate matter. So you can capture a lot of different things within that cell or pixel data. But then obviously the modeling and then the technology required to do that for either for these two different data types are pretty different. But for this discussion and then walkthrough, I'm mainly going to look at vector files. In the Python command line or in your IPython notebook. I think the closest you'd get to this is if you have to download and learn how to use QGIS. and then integrate those features. So that in itself is another class. So if you wanted to work on raster files in the next 2 weeks, I would say don't do it. Work on something else.
There is Phil, the Python image library.
Yes. Okay. Yeah. No, that's true. That probably raster you might use. There might be extensions to like photo imaging, right, or photo computation. That is probably would be more synonymous to that versus some of the files that I'm working through. So PIL is good. Well, I'll add that to my list, but it won't be featured today. So they are the two different data sets. We kind of go over them slightly a little bit more. So points, lines, polygons, very discrete shapes with boundaries. And they both have different types of database management, where for vector files, you can manage it, each feature more like you would manage like a CSV, where like, you know, latitude and longitude is its own column. So it's like a little bit more similar to that, where for instance, you can have vector GIS data in your pandas framework, and then there's an extension to pandas called GeoPandas that can do that as well. And then, so since that's kind of like an easier way to represent data in terms of how, like, you know, current databases are working, there's also extensions to storing and querying vector GIS data. When it comes to MySQL has an extension, Postgres has an extension, and then MongoDB as well as Redis has an extension too. So yeah, these can produce very high quality maps and very like human readable maps, what we're used to, because it essentially you're like just layering like you can layer a high image resolution like base map and then put lines on top of it. Versus a raster file, because it is pixelated, that, you know, depending on your processing power and how you want to display it, it could be more fuzzy. The surfaces are essentially continuous, and there's no breaking point in between. You can break by pixel, and it's good at representing dense data. And then it can capture change over time better than vector files, or if at all. And then it's very good for spatial modeling, especially with like agriculture, sustainability, and things that are slightly nuanced. So again, kind of like looking at the attributes. If you were to weigh essentially which one you would use, the deal breaker is technology and processing time and data volume. If you can handle larger data and you have like an efficient system to do this, then you'd probably go for raster. And then obviously the type of analysis you want to do. Like if you want to do more measurement, area, length, distance, then vector would be pretty straightforward. And then here's a list of some files that you might encounter. So as you would imagine, raster is more image-based, pixel-based. So it's TIFF, JPEG, ECW, and then vector goes more with GML, which is a markup language, and shape files are the most common. And then as well as there's other like storage, data storage formats like GeoJSON or regular JSON as well. You can still store regular CSV. When you work with Google Analytics or Google Places API, they will come back with a JSON file so that you can plug into any package. So some examples to think of when you're thinking about GIS projects. There's data projections for market analysis, and how that normally goes is you draw a polygon. If you're a salesperson and you split up a territory, you can draw any random polygon you want, or take the existing polygons that are there, and then use census data or use geographical data to any granularity, and then you would map kind of the propensity of that area. Oh, who has a higher income? Who likes cats more? If you're selling cat collars or something, so then that's pretty common for market analysis. Like Google does that. Facebook was doing, I heard they were doing this project on, in third world countries, thinking about where they can put down more Wi-Fi or like, what's it called? Broadband. So they did, I guess, a market projection based on this, based on income and based on like location and proximity to existing infrastructure, and then mapping where it would be most efficient to work on that, as well as, so the next project that I worked on this vegetation and elevation projection and modeling. So in my last company, one of the things we worked on was looking at space images and then figuring out kind of water consumption by property in terms of what vegetation they had on their land. So obviously if you have grass, then like that takes a certain amount of water versus a shrub versus like dirt, which doesn't need anything, right? And then also, I mean, from that you can also calculate kind of like, I don't know the right words, but like how much water the soil would absorb. So then like how much rainfall would be absorbed by that area. What not? Yes?
Solubility.
Yeah, okay, yeah, solubility. Obviously I didn't write that final report. and then we had an app in my previous company that was sold to governments where they would, for agricultural land and non-residential land, they would calculate and project water consumption, and then that could influence policy on what kind of vegetation or landscaping they would allow in the future for businesses and agriculture, as well as transportation modeling and prediction. So this is also very complicated, and I used to work in transportation policy as well. And so one of the laws is every 4 to 5 years, a MPO, so Metropolitan Planning Organization, is required to do transportation modeling, which is a projection of how many people live in a certain place, what their transportation kind of needs are, and then by time, by day, and then see like congestion on the road, how many cars they expect per person, and then those outputs are where they can change or update land use laws. In California, the most recent kind of application of transportation modeling was also to project VMT, vehicles per mile traveled, which would predict emissions and then would go towards some emission targets that the state had for different counties and cities. So that's definitely a mix of raster and vector analysis. They will use X percentage of them will use this type of transportation versus this transportation, and then measuring load. Who are opening up their data sets. One of their most inquired data sets are GIS data. A lot of it's not surprisingly, in the recent months have been transportation, especially bicycle and pedestrian planning, and their crime statistics, which is definitely relevant here because usually crime data has location of the crime, if not address. And then also, and I guess in the private sector, or this can be public too, web analytics and social media is used a lot for location-based information. So you can do market analysis, user segmentation, kind of where someone lives is very indicative of their behaviors and what they'll purchase, what they will read, and what they'll look at. So that information is definitely highly coveted, but now that people are getting smarter, which is a good thing, they have deactivated their location sharing. So most of the social media that I use don't have location as a parameter that you can use. So just quickly through some of these tools. So I'm not going to walk through these suites of tools because they are rather cumbersome And I think a lot of it's learning what exists on their interface and then clicking the right buttons. So as you know, Esri is kind of the foremost provider of data as well as infrastructure for GIS. I think they have an office in Redlands, and in this, like, I think it's like an hour or two east of here. But they have ArcGIS and ArcSDE. They have a very small open data sector, which actually I took the data science class with one of the people that worked in that sector or spearheaded that sector. But I think it's very, very limited, and it's like one of those like innovation licenses. Like if you have an app that you want to put into the public space, that you can maybe get a limited data set from them, but obviously you probably have to pay for that after a while. And from what I know, in their like enterprise license, it's super, super expensive. It's at least $10,000 a year for one user. And I think that's like the base level, which you don't get everything. And then the next tier is Google Maps, which is, they have a great API. They have obviously tons of information, but if you ever want to go from free to enterprise, it's also quite expensive. And their limited API is like pushing a lot of people to move towards OpenStreetMap and OpenTripPlanner, which is pretty good. And the package I'll walk you through, Folium/Leaflet, is based on OpenStreetMap. And then QGIS, which is, I think, you know, the open source GIS tool that you can use. And then geospatial databases, which I mentioned earlier, they are these databases using and storing geodata in the right geospatial database can add a lot of efficiency in your life, because it can store a line and a polygon. It'll know it has a data type line. Just says they have data type integer, data type text, or data type, you know, varchar, that they have one as line and point, so it identifies what it is. Oops, and I meant that to say polygon. So then you can sort on it, and then you might be able to, depending on which one you use, sort on area, you know, based on that polygon, and then you're able to find basic intersections. Like I think you can do basic union. So you're like, oh, this shape overlaps with this shape, select it. And then, however, obviously, if you want more higher level or complex analysis, you have to read the data and then do it in whatever system that you have. And then so here are some sample queries. I don't know if you can see it, but you can see this is just like SQL. So you select city, superhero, and then this is like a function this is a Postgres extension where you're asking for whether something contains that city and that's that superhero. So, and then it would output that information for you. And this is from MongoDB, which essentially has, you know, a function which lets you search for something, for a location near something. So you can say, hey, I want this near this point, and this is the distance, so that's like essentially the circumference, and it gives you like a limitation to your search. So it could be obviously very efficient for your particular analysis that you want to do, to not take all your data, especially if you're working in memory, not take all your data and put it into memory and then analyze it. So limiting that could help your life a lot. Okay, I'm just gonna mention these and then we'll do the demo. So there's ArcPy, which I think is part of the Arc suite. I have not used this, so I'm not sure if it's free or not. I bet you they have a free level, but I'm not sure if that is an API. And then I suggested downloading Fiona, because that gives you the standard reading and writing in the Python IO style. So you can, like, when you do read CSV, or your write lines, write row, you can do the same thing with Fiona with shape files. and shapefile is a very unique animal that it's not comparable to any other format that you've worked with. Shapely, I think, is a pretty good one that integrates with GeoAlchemy. There's GeoPandas, which essentially uses the line polygon objects, and you can manipulate them in GeoPandas and visualize them. And then Leaflet Folium, which is it's a good, I think that's like the best package for the basics because it's pretty and everything is there already for you. Oops, look at it. Okay, so I'm gonna do the demonstration and then I'll share this presentation with you, and because there's some interesting links here that you could probably make use of. So I'm gonna close this, move it back here. Okay, I'm gonna pull up this thing. Oh yeah, I'm gonna walk you through so who here knows like virtual environment, how to set up a virtual environment? Okay, so then if you have Anaconda, you can open up Anaconda, which is, I've talked to some of you and some of you don't have this. Do you guys have this thing? So Anaconda is pretty awesome because they just have it for you there. Where like you can go here, because see, look, my base Python is 2.7, and I use this one, GA-3, which is Python 3, to do like any work that to kind of, what's it called, give you comments or whatnot with this. So if you open this up, you write new environment, and you can say whatever you want, blah blah blah.
Also, to get that, you could just use Spotlight and type in launcher. It's like command spacebar. Just look for that icon, the little green. It's hard to type that.
Yeah, what's it?
Whatever that is.
Anaconda launcher.
Or just launcher.
See if I have it like this, like that. Here, go ahead, just have launcher.
Well, you said you also want to make sure you name your environment something unique. Remember, you're like, if you have a file name that's similar to your environment name, then it's confusing.
Oh yeah, I've had it where like I was using a Twitter package, and then I was naming my file. I named my file twitter.py, and then you know there's a package called Twitter, and there's a virtual environment called Twitter. So it's kind of like, you know, just to make sure your computer doesn't get confused, because it did for me. It mixed up the package though, and then my Python script. It just kept erroring. But anyways, yeah. So do Twitter _DNV virtual environment. Then select your package, submit. And this is awesome, but if you don't have this and you want to do it, there's multiple ways. I sent you that link to Continuum. There's also a pretty good virtual environment package that I used a lot with pip, using pip install and setting up this virtual environment here. So I'll Slack this to you guys, but this is pretty awesome. It's just pip install virtual environment. This is another option, but if you're using Launcher, it uses the same idea, essentially. But this one is, I think, pretty good. So I'm gonna stick with this one. I'm gonna stick with the Launcher right now, so I don't confuse anybody, but I'll just Slack you right now. It's just like another option. I think a lot of people use this one too, but it's the same idea too. Package, another option. Is everyone good? Oh, okay, yeah, yep. So basically, where it goes is it goes into, you know, your a bin file, which is which you have two options. You can link it in your bash, and then when you call it, it'll bring it up. Or if you wanted to, you can like CD all the way down into your bin, and then there's essentially an executable file that if you like execute it, it'll like bring up your virtual environment. And what it does is just it packages up something. It packages up all the things that you download into that package. And it doesn't affect anything else. So if you download, like a package into your virtual environment that's not anywhere else, it won't show up anywhere else. But it also won't interact with it, and it won't. So if you like delete, erase, and you do something, it won't blow up your computer. It'll blow up that virtual environment. You just delete it, and then you start over, and then your computer is like safe. So essentially, it just creates like wrappers where you can work on things. And
there is a question. Like I just created an environment. Saved it. I saved it. Now I can't seem to find it.
Okay, so then like there is a way to activate it if you do the launcher one. So you can test it. So you can either look at your launcher, or you could do for Anaconda, it's just source activate, and then your virtual environment. And then can I? Yeah, source, and I'm just doing the tab thing. It doesn't do this, it doesn't show you the tab thing. But let's see. So you can do, for me it's source activate. Oops. Source activate, I'll just do GA-3. That's my one example. So if you see from here, you'll see like right now when you just source activate, that's like essentially, is it symlinked? I don't know how to say it. Symlinked, or like a command that Anaconda automatically knows. It goes into this path and it activates your environment. You see right here. And then you're in your virtual environment when next to this prompt, your virtual environment name will show up here. And then if you want to get out of your virtual environment, just deactivate. And then is that helpful, Mike?
Go back.
Hmm?
Go back.
Yeah, virtual environments are used all the time because like you might have different Python packages and all for one website, and then different ones for another one, and then you do this other project which uses Python 2, and this other project that uses Python 3, and you can just switch between the virtual environments. So you can install different packages every single
Oh yeah, so then okay, so in your launcher, are you in your launcher? So you can look you can look at your launcher. If it's there, it's safe to say it's there. If it's not, probably not, right? So that's one option. The other option is to go into that bin file. Work this out. You can go into your, hold on, let me pull it up.
I'm getting an error. Can I create?
Uh-oh.
Yeah, when you name your environment, usually it's just in all programming and stuff. You should probably make it all lowercase without any spaces or special characters.
Ah, yes. Oh yeah, so then for instance, I created a Twitter _BNB. So then let me just do it again. Source, activate, Twitter BNB.
Source.
Okay, but then if I wanted to like kind of look at where my virtual environments are,
And then space.
I'll do this. CD.
You're in the
Okay.
Maybe it's not my
all it does is switch. So all the virtual environment does is like when you type in Python, it switches where it looks for that Python executable. So it creates a new directory with different executables in it. And so now when you type in Python, it looks in that other directory for Python instead of the original one. That's all that virtual does.
Python 2.7. I don't know if it's possible.
Okay, so then like, so also, okay, so then like, well, you know when I activated my bin, it showed me that location. So it's actually in your root file. So if you go to cd users, whatever, and then you keep going down into it, you can see right there is all the 3 environments I created in Anaconda, and then I can also cd into it, and then essentially you can cd all the way down into the bin file, and then this is the bin file with all my packages in here, and then there's right here you see this is activate. So like essentially it's just like there's a executable file in there that activates when you do source activate your particular virtual environment. If you wanted to, you could do deactivate. Essentially, you could also start it by just you can do. Essentially, like see that path right there? You could cd into that path and just start the virtual environment from there, but source activate is much cleaner and easier to do. So yeah, so you just function as though you normally would. And then, but then I think, so some people also use this too, is like, if you do let's say you do a study, like you're doing medical study, and then your computer is configured a certain way, and your whatever, and you have to create a replicable study, then like you want everything in your environment to be the same. Like some people will go to the extent, I don't know if they still do this, is like they have one computer that worked on that report, and then when they're done with it, they unplug the computer and put it away. You know, like I think back in the day they used to do that because it's like that's set up with the exact variables for that exact report. So if someone came up to you and was like, replicate it, they pull out the computer and then do it again, you know? So it's like kind of that idea where like, yeah, I mean, but I mean, there's no guarantee necessarily, but like, so sometimes when you pip install a bunch of stuff, you don't always need something that you downloaded 3 months ago. I don't remember what it is even. So like a lot of times I'll just always start over. So I always know what's fresh in my environment, and especially in a work setting. If you have too many packages, especially ones that like are not updated, there's a security risk. So like I always know what I'm uploading, and like if I'm pipelining something or if I'm running an application, I know these are the most recent packages. And I'm using only what I need. I only have in there what I need. If I don't need it, it's not in there. So a lot of times when you can go pip list within your environment, and there's a lot here, but then like it'll give you this list of requirements. And a lot of times if you see apps, it tells you, hey, if you want to run this app, you need these packages. And it's really, and then you can do like you can import that list and just upload everything on that list. So there's multiple ways to do it, multiple reasons why you want to use virtual environment. Okay, let's see. I think that's it for virtual environments. And then like this is awesome because then you can just delete it. Super easy. I think this is like one of the easiest ways I've ever used virtual environments is in this context. And then so in like if you wanted to use virtual environments in this context, you can all you do is you set your virtual environment here, and then you can open Spider and Python or IPython notebook, and it'll launch from there. Or also within each IDE, there's also like a configurations menu bar, and then you can set your virtual environment to it as well. Okay. So, any other questions about virtual environments? Cool. Let's see. Okay, cool. So I'm gonna pull up this. Oh yeah, I'm gonna walk through a couple projections to let you, to just give you an idea of what what projections, where is this thing? 1 second, I'm just gonna pull it up. Oh yeah, so this is a pretty cool, this is Matplotlib base map, which is another package. And they essentially, they have very common projections. I think it's kind of cool to look at because I like maps. And then we're like, you know, this is this projection. So I'm kind of not going to humor you and say it wrong. So essentially, you know, that's one projection, and these are the like elements in which you would use base map to have that projection. So I guess if you wanted to like, you know, map the trail of sharks through, where's this? Atlantic, Arctic, Antarctica, Arctic.
Some bottom.
Oh yeah, Arctic, whatever area, then like you'll use this map. Or like, was it the penguins live up here, or they live in the south?
What's that?
Penguins south.
So okay, so no penguins up here.
No, because there's no land. It's
Oh,
just-
seals and Santa Claus. Yeah, perfect. Seals and Santa Claus. And then war too, because people are like, right, they're fighting over that area. It's an Arctic Circle. And then I think this one's a pretty common one. Mercator, transverse Mercator. I'm sure there's a lot more details that go into this. I'm not going to pretend I know everything, so I'm going to leave it to you if you want to keep reading about this. And then if you find anything cool and interesting, I'm happy to read it. And then transverse Mercator, I think this one's used. But this is obviously like when I looked at some examples about the UK, they obviously use this one. This is pretty vain. They have their own one. I couldn't find one just for the US. I think there is a specific one, but it's not on this list. Let's see, one more. Let's see, Lambert, Albers, equal. There. Oh, this one's like Western Europe, Eastern Europe. That's pretty cool. All right, so that's also linked in my presentation. So if you are interested in any of that, then you can find a base map that way. And so what you do is you usually in the programs you upload a base map, so one of these guys, and then you draw polygons or lines or whatever you want on top of them. Okay, cool. So this notebook is mostly pushed up into the repo. So if you wanted to walk through this, you can look at that. It's in the folder Python GIS. And essentially, you know, like one example that I wanted to just show you was like using Python Folium for mapping. And most of these maps are included, where like a lot of other packages, you have to do your own base map, select your own base map, find your own like polygons and whatnot. So then one suggestion I had is that you could go onto LA, the open data portal, look at their data catalog, and generally in their map section, you can download to your heart's desire things they have there. So they think they have like crime data sets, they have lobbying data sets, and then I downloaded here like a list of affordable housing. So I downloaded a CSV of where it lists, and the data's pretty decent where they had latitude and longitude of affordable housing units in LA. And then we will also probably need LA County, LA City, wherever shape files. So it's like the base map. And you can download them here in any of these two places. I think this one is the open data portal of LA. And then I use this person's code a little bit to show you. Okay. So essentially, I downloaded, let's go there, I guess. Oh, it's in, where am I going? GitHub. It's in, oh did I push it? Maybe didn't. I thought I pushed it. Let me just do it right now. I pushed it. Code. Huh. Okay, let me just double check right now. GitHub problems. You guys all know. Struggle's real. Never dies. Oh, wait. Hold on. What? This is kind of weird. Hold on. What did I do? Yeah, I did this. It had it commit. Oh, git pull. Oh, for those of you waiting, I guess you can look at download a coordinate system from the Open Data LA. Or just like a CSV from here. I was just saying here, you go to catalog, and then go to maps. You can look at the map, and then you can download it. So I downloaded affordable housing. You can do bus routes, which might be a little more complicated because it's lines. If you just want to start with a point, then you could go maybe here. I guess we can do. I mean, there's a lot. So let's see. What's another one? Probably permits might be one. Or I wonder if they. In my mind, I was like, maybe they have like something to do with like water consumption, but. It says it updated. Yeah. Merge made by recursive. Get down. Yeah, should be up here. It should be in homework datasets Python GIS. Oh, do you have to merge? I don't think so. Well, I don't have a branch. Huh. Origin master. I'm confused now. See, look, I have problems too. It should be here, Python GIS. Yeah, it should be a new folder. It says it did it. Python GIS. I have write access to this, right?
I think you're contributors.
Yeah. User email. GA students. Yeah. Git pull, git push. Yeah, it should be. I did that earlier. Okay. Let me see this. You know what's funny? It's like there's only like a couple commands you ever use. Oh, here, it's right here. It's only a couple commands you ever use. It's like, always get confused. It's only 3 or 4. Okay, cool. So it's here. Dun, dun, dun. And then, I downloaded this one already. So you can just you just used this notebook, you could just use this directly. So. Cool, so then, I mean, essentially you can just substitute, at least for points, you could substitute any CSV file that you download from the open data source here. As long as there's a latitude and longitude, you could do it. And I think for the LA open data, most of it's pretty good. I also used a different data source where I looked at lobbying projects, and then I used Google Places, and I sent Google Places API the address, and I got back a latitude and longitude. So that's another thing you can do, but I didn't go for it here. I mean, for this one, there's a lot you could do too. You could look at we have like jobs that are created from that particular project, and I'm sure you can guess why. It's like affordable housing is kind of like a pretty political subject, so they want to show the best they could that there's like a positive impact on society, and jobs has been the past 5 years like a key word for the politics. So they have the number of jobs, the name of the project. They have a lot of other stuff, but obviously they took it out. Here they have project number, council district. So I mean, you can also if you were doing like some lobbying issues, you can see who supports affordable housing and who has the most affordable housing, kind of what that means. Because also there's ramifications. You build a site that's affordable housing, but that replaces a kind of luxury condo situation, then you probably lose some lobbying dollars. I know someone was doing like a political lobbying project. That could be something interesting. Finish here. So I only brought in like these couple things, and I didn't really necessarily do any modeling. So then the nuance here is basically for all these packages, and you've been learning, is like you have a data set and you kind of question for that data set. You have a package that you want to shove that data into, so you define the correct way to format your data so that like the package will take it and spit out stuff that you want. So that's very the crude way of saying it. And so essentially for these GPS coordinates, it comes kind of like these GPS coords come out in a pretty interesting way. Where, let's see, it's already there for you, but it has parentheses instead of. Obviously doesn't like it. I lost it. Here, oh yeah, it has parentheses instead of brackets. So then Folium doesn't like it because Folium requires brackets. So let's look at Folium for a second. Okay, so I'm gonna go for like 10 more minutes and then we'll go on a break. Oh, and Folium is awesome because I really like it because it takes Leaflet, which is a JavaScript-based package, and it translates it. And it lets you produce like pretty nice graphs. So here you pip install Folium into your virtual environment. And then essentially like the very basic way of just mapping your data is.
It's right. It's a virtual environment. Just means anywhere.
It means anywhere. Virtual environment just like is a better way. It's a better way to do programming overall. Because like you don't always want to, because you want to delete stuff, but you don't want to like use that delete and ruin something else you did before. So kind of like, it's also a conservative way to kind of like build your environment. Because for me, deletes are always scary. I'm like, I'm gonna delete this, okay?
Yeah.
You know, as long as I have like a way that I know there's a backup where I won't blow things up, then I feel better about it. urban streets maps, and it's pretty straightforward for just mapping points. So here, like the beginning is just like getting those points to the right format. And the one thing that it needed to do was convert these parentheses into brackets. So I did it this way. There's obviously a multitude of ways you could do it. I applied a lambda function on the Panda data frame. And then like there wasn't any null values, but I just checked it out. And then so this is one map. Let me start from the beginning, make sure I ran this. So the very, very basic, so this is just, I just picked a random point, and this is the one that from the presentation I just wrote, just Googled Los Angeles lat long. So what this does is just, when you call this package folium.map location, and just basically one point, and then you can select whatever zoom, and there's other components of that. It just essentially sets the base map for you. So if you wanted to map something in Africa, you'd find like your centroid, the center of the map of Africa, and then put that in there, and then you can do the rest of like whatever you want to show from that continent, like mines, blood diamonds, whatever. What's the not all negative things. What's another thing like oh my god, I was gonna say dead lions. Oh, sorry. But basically what you would do if you did that, then you would start like advocacy, right? And be like, oh, save the lions, or like, and be like, hey, let's stop this, and that's information is power type of approach. But anyways, definitely think it's like I think mapping has been really powerful in changing that. I think like no, just any type of situation where like where like you want to change something. Well, yeah, probably because you could call attention to like the area. But anyways, it's a real issue. We should talk about it. So the next half of my presentation is about issues you don't want to talk about. And then, well, we'll have break in like 10 minutes, so you don't have to stay for that. Okay, and then I think I really like this format. It's pretty simple, pretty super straightforward. It takes essentially like so then you set your base map, and again we're gonna go back to like Python way of creating a map. You're just gonna layer stuff on top of your map. And then like in your matplotlib, GG plot packages, that's all the same too. You set a base, like your base axis, and then you layer on top of things you want. You layer on your legends, you layer on like your points in different colors and whatnot. It's the same idea here. So this is the simplest way to do it. This is one marker. This is the first data point from this data set. Stick it on top of here. If you want to do this, like they have this pop-up text available. This pop-up text has that. Add pop-up text, and that uses HTML format, and then you print out the map. So then you also have it also prints it on HTML, so you can serve it on whatever website you want, because it's obviously JavaScript based, and then or you can just use this. I just created a definition on top, a function on top, where you can just display it. Oops. Embed or inline or embed map. Right, so there. And then they're just playing around. And then alternatively, if you have many different points that you want to plot, you just it was layered on, right? And then so this one, you could do, you can change your markers. You can also have clustered markers equals true. And then, kind of show whatever situation you want to show here. So this is LA affordable housing. You're like, oh, where is affordable housing? And you could probably guess where it is and where it is not. Oh my God, are there any affordable housing here?
Cheaper than.
Well, I used to do affordable housing advocacy, and then the way the affordable housing units that they build are really, really super nice nowadays. They're no longer like, the stereotypical back in the day, like the project style. They don't do that anymore. Because that was an experiment that they got from Switzerland, and it worked for Switzerland, but then they brought it here and they're like, oh, it doesn't work. So that's my plug for affordable housing. Okay, and and then potentially, so then you can also, Folium has an additional component where you could also bring in, like I said, like a base map, and then, do points and polygons around it, and also do this style mapping. And I was having trouble with showing the different colors. So I'll work on it and update this. Essentially, like, this is showing the unemployment rate for 2011. And so the basic function of this package is this GeoJSON approach, where so this GeoPath is the JSON base map that you download from the sources that I provided. Data out is where you want to export your data. So then, like, this essentially shows you kind of like each little square that you have, and then like what value it's supposed to get, and then so you know what color it was supposed to get. Your data frame, so that is in this instance, it's list by county or by FIPS code of different attributes. So here there's median income and there's like unemployment rate. So then essentially it's supposed to have different colors, but I couldn't get that to work. Eventually I will, hopefully. And then your threshold scale. So even though the employment rate here is percentages, so there is it's scaled to this value. So 5, 6, 7, 8. So essentially it's supposed to colorize based on this threshold, but it's not doing that right now. There's a lot of different, this has pre-packaged fill colors, and then legend. And I was having trouble with this. So I commented out. I'm guessing this is what's giving me problems. So this topo JSON is supposedly, it's an extension of this JSON file that I'm getting from a different source. So I'm imagining that there's something wrong with that mapping or that translation. So okay, and then kind of similar, try to do something else with another map, but it didn't work. And then, so geometric data is not just maps. If you want to, plot a point, you can also use a combination of NumPy, Shapely, and in this package, Descartes, which is like probably famous mathematician, right? And so then with this, you can, really you can plot points to your heart's content. You can plot polygons, patches. You can see, Oh, buffer is circumference. So this is like a square. Sorry, a circle. So it's like this is the center point, and then this is the area around it. And then, so then also, if you see that what I've done here, you go patch equals point 0, 0, buffer 20, and then you get the area. So this is a function also of that package to calculate the area.
What's that? I'm sorry. What units is that value? 1, 2, 5, 4. Is that kilometers?
Oh, I think it's no value. There's no, but it's just straight quantitative, like 20 as a unit. It's probably, was it like pi r squared, right? I have to double check that. Pi r squared is probably pi r squared.
Manipulation of latitude, longitude.
No. Oh, sorry. So this one, This is starting from scratch. Has nothing to do with the latitude and longitude.
Okay.
Nothing to do. So this is set to coordinate system based on these 2 points, which is x and y. So just on an x and y scale, the point is 0 with a a buffer of 20. So I think that's like the radius is, the radius is 20 of the double check.
How do you, sorry to interrupt you, but like how do you integrate that point with like an actual, with that, something in the real world?
Oh, okay. So if you wanted to calculate area, we would go back to Folium, and then they have area functions that you can find. Let me just look for one with you. Okay, so this is also real world. I was just the message in this part was just to show you that geometric data is not just maps. Latitude and longitude is a component of geometrical data, and so like if you had different things you wanted to map, like different things calculations wanted to do, you can draw points, calculate the area, and you can definitely within this construct put in units of measure that you want, as well as polygons, patch differences. So you're looking at I didn't print this out. Just start from here, I think. Anyways. And then so you can draw lines, right? But then you can also say here, you can also ask the program to tell you whether a line intersects each other or a shape. So then from here it says, oh, blue line intersects clip shape. So you can draw like random shapes and then intersect them. And I guess this probably has some practical application to definitely to like I was talking about land use. When you're saying, okay, this random polygon that I'm using is used for a transportation corridor. This is residential. And then I guess you would, when you model it, you could say like, does one overlap another? And that has like certain consequences over the other. Okay, so I'm gonna go back to your original question with like, with the Folium. Okay, so Folium essentially is more visualization and not as heavy calculations. So let me I'm just double checking the package. I don't remember. Yeah. So you can bind data to it, and then essentially the calculation that you would do for Folium a lot is a lot of this style map where you use different base maps. You can do by state, by zip code, and then show kind of the different values that this bound has compared to the other bound. So here it would be like, if this came out correctly, you're like median income, this is darker than this is higher than this. So you're making a comparison. If you wanted to do more like deep calculations, then I would suggest using Python Shapely, which is more manual, like more manipulation and analysis of geometrical objects in the Cartesian plane.
So on.
Okay. So then, is that what you want me to get to?
Yeah, actually, that's something that I'm struggling with my project. Is segmented, basically a city into regions, so that rather than have all the latitude and longitude in one area, it's like block. It's block one, the next spread you over many decimals.
So right now you're using city as your base map. Is that correct?
I mean, I'm not using it. I just have like a ton of GIS data.
What's your final question you want to show or answer?
To predict the trajectories of taxi given
trajectory of a taxi. So that would be a line. Ooh, that's like really complicated.
Right. So I just wanted to know like how to basically, instead of like writing a line as GPS points, right? Instead of having it latitude longitude, you say this is in region A, it goes to region E, and then it goes to region D. do that? How do you
Okay, so what you would have to do is you have to choose your base map, so your lowest like area. So essentially you have to use you have to select your base map. So you're like, oh, it's because otherwise if you want to do region, like a very customized region, you have to draw your own polygons, which for everything. So then and what that is essentially is like a collection of different points. So you'd have to.
what I tried to do is I just tried to find the maximum, the minimum values
Okay.
For these strips. Right? So
draw your own regions. One of the lowest tracks is like census tract, right? So maybe you'd use
it's
census
not
tracts.
US.
Huh?
It's not US.
Okay. I think it'd be kind of hard. Actually, maybe QGIS would let you draw your own polygons. You have to learn it. And then, but otherwise, different cities, which country is it, have,
Portugal.
okay, I don't really know their system, but I bet you they have like a zip code type of approach. And then so you would find their central zip code base map right here. So and then use that to say, and you can use Shapely. So let me just finish up really quickly with Shapely. Just use Shapely, and then Shapely will let you ask. Did I get through this? No, I didn't. I actually didn't run through this as much as I wanted to. It can essentially tell you where. Yeah, I didn't get through this part as much. But anyways, Shapely is better off at telling you when you have a base map. I couldn't run this very well. So you can put in a base map, you can draw coastlines, you can fill the continents, and then draw all these different boundaries that you want.
Where do you find the base map?
Oh, okay. So I know this is not a U.S. country, but then U.S. you have to essentially use what other people have done, unless you Let's see. I have it down here. I have it in here. Oh, here. Is it here? Let me find it. Here, shapefiles. So essentially it's here, or LA County, and I think a lot of US cities open this up, where you find the different cities. This is city boundary, city annexation, city county boundary, and they have this folder, essentially, which I downloaded already, has the files that you need. And so that's why I went kind of basic this time, because GIS is it's a little bit more, it's a subject that requires slightly more practice, but then essentially if you can find something like this with all these attributes in here, then you would use this as your base map. Okay.
So this is it's just a specific file type.
Yeah, a shapefile is essentially one of the, and in my presentation I showed other file types. Shapefile is one of those files that have it has embedded in it, there's projection, translations, and attributes. They have attributes in there, and they also have lat long, essentially, and points and polygons. Those are different parts of shapefile as well. Because look, they also have this projection file. Okay, cool. So any other questions? I'm going to update this one. I'll update this to actually show the different colors this week down here. And then if you have any questions, I didn't really think that people would get too complicated with GIS. But essentially, you have something where you can, if you have whatever presentation you're going to do, you can show it on a map, and then we'll just make it look pretty. Okay. Thanks. Yay. Thanks. Hope that was helpful.
It's really impressive you got lot of that working. Because,
Oh, this?
yeah, a lot of the GIS stuff.
Oh yeah, it's pretty cool, but GIS is like definitely, it's a